Hello and good day, Doctor. My name is Winki Wong, and I'm here today to present my final year project 1. The title of my project is Vision-Based Mobile App for Obstacle Detection and Speech Interaction Using Deep Learning. So this presentation is structured into 5 key sections. I will begin with the introduction to set the stage for the projects, and this will follow by a literature review where I will discuss the current landscapes of existing technology. After that, I will detail the methodology I plan to follow for the development of applications. The 4 sections will cover the requirement analysis and design, which form the blueprint of the systems. Finally, I will wrap up with a conclusion, summarizing the projects and its expected outcome. So let's begin with the introductions of the project. The core issue this project addresses is significant challenge visually impaired individuals face in their daily navigations. So first, the traditional mobility aids, such as white cans and guide dogs, while essentials, provide limited support and do not offer context-aware feedback about the surrounding environment. Second, the existing applications like Seeing AI, Surveillance Plus, and Lazarillo often have limitations. They may require manual input from the users or lack of the capability for the real-time detections of immediate hazards. This leads to the third and the most critical problem, which the absence of real-time spoken feedback in dynamic outdoor setting places visually impaired users at a considerable risk of accidents and injuries. The primary aim of this project is to create and develop a vision-based mobile applications using deep learning methods. You only look once, or we call YOLO, that help visually impaired individuals by detecting physical obstacles at outdoor area in real time and providing relevant verbal alerts using the speech. So to achieve this aim, I have established 3 main objectives. The first is to identify and analyze the type of the obstacles and the challenges encountered by the visually impaired individuals in life. And second, to design and develop a mobile applications that can to identify obstacles in public areas and warning the visually impaired individuals when the obstacles detected by using the computer vision algorithms and deep learning. And the third is to evaluate the accuracy of the object detections and the clarity of speech interactions in the mobile applications. So to ensure the project is both feasible and impactful, I have identified a clear scopes where an Android mobile app will be developed to assist visually impaired individuals using the computer visions and AI voice interactions. Second, a YOLO V8 model will be trained on custom dataset to detect outdoor obstacles and convert to TensorFlow lead for mobile performance. Third, a fine-tuned DeepSeek AI model will be generate context-aware voice feedback, which will be spoken aloud via Flutter text-to-speech. Then, the app is designed for chest-level camera usage to reflect users' field of view in real time. Fifth, user testing and performance evaluations such as F1 score, mean average precision will ensure the effectiveness and real-world usability. And lastly, our target users for the applications include the individual with permanent vision loss, senior with transient vision impairments, and individuals with extremophobia. Now I will move on to the literature review, which provides the foundational knowledge for these projects. So to understand the current technology landscape, I have conducted an analysis existing applications. So this table compares the features of the popular apps like Sing AI, Lookout, and TapTapC, and also includes proposed solutions by a research, which is obstacles. As you can see, while this existing application provide valuable functionality, there are significant gaps. So my proposed systems will offer a real-time obstacle detections, contextual voice feedback, and completely hands-free use. All of these are crucial for independent outdoor navigations. It will also include a history preview and directional feedback. So next, I will discuss the methodology that will be used to guide the development of these projects. So for this project, I have selected a hybrid agile waterfall methods. So the process is begin with a requirement analysis phases, which follow a traditional waterfall approach. So once the requirements are set, I will transition into an agile cycle for design, development, and also testing phases. So this iterative approach provides the flexibility to make the adjustments and continuous improvements as the project progresses. So if any issues that are discovered during the testing phases, I can easily look back to the design or development stages to address them. So this slide provides a more detailed look at the 4 phases of the project methodology. The first phase will involve the studying of the problems and obstacles that visually impair individual space, researching deep learning models and text-to-speech technologies, and analyzing existing applications to define the system requirements. And then the next phase is where I design the mobile applications user interface using Flutter SDK. And I will also design the detections model using the YOLO VN and TensorFlow leads, and design the speech interaction using Flutter text-to-speech and the DeepSeek AI model. And the next phase is the implementation stage. So in here, I will build the app in Flutter, train to and test the YOLO VN model on a custom dataset, fine-tuning a large language model, and integrate all these components into a cohesive system. And lastly, I will conduct a usability testing with both sight and visually impaired individuals, measures the object detection's accuracy and app performance, and collect user feedback on the clarity and usefulness of the speech feedback to validate the system effectiveness. So to successfully develop these systems, the following table are showing the hardware and the operating systems that might be used for the development. So a laptop with an Intel Core i5 processors, 8GB of RAM, and an RTX 2050 GPU will be used for the development. So for deployment and testing, I will be using the mobile devices running on the Android phone. So various types of earphones, including wire, Bluetooth, and bone conductions, will be used for the audio output. And for the software, the primary IDE will be used is Android Studio, which is for building and testing the Flutter applications. And then the Visual Studio Code will be used for writing the Python and Dart scripts. For documentation, I will be using the Microsoft Word 2019. And for the system design tools like Draw.io and Figma will be used too. So now let us dive into the specific of the requirement analysis and the design of the systems. So this use case diagram illustrates the interactions between the users and also the systems. The primary user, who are the visually impaired individuals, will interact with the system through several key functionality. So this includes providing the real-time video input, which require granting camera access. So the system will perform the obstacle detection and analyze the detections. After that, it will provide the vibrations, alerts, and context-aware messages. So the user will also receive a speech feedback and have the options to view the history of detected obstacles. So the architecture of the systems is designed around the MVC, which is Model View Controller pattern. So it's implemented in the Dart and Flutter for the front end. So on the back end, I will be using the TensorFlow lead for the on-device processing, so which allow for real-time detections without the internet connections. And we also utilize the Firebase for the back-end services, including the authentications and real-time databases. So these are the sequence diagrams provide a step-to-step illustrations of the interactions for the key functionality. So the first one is about the real-time video input. So the diagram is showing the process of the user starting the applications. Then the system will tracking for the camera permissions, and then either starting the camera if the permission is granted or keeping it idle if not. And this diagram details the continuous loop of the applications. It shows the camera capturing the environment, the system performing obstacle detections, storing the result, and then displaying the results and generating the speech feedback for the users. And lastly, this diagram explains how the users can navigate to the history interface, select a specific detected obstacles, and view its detail, which are retrievable from the application database. So the database for these applications is designed with 2 primary tables, a users tables and a detections tables. So there are one-to-many relationships between these tables, meaning that one user can have multiple detection results stored in the database. Okay, finally, we reach the user's interface. So for this slide, it shows the home interface features a large and easy to tap start obstacle detections buttons, making it straightforward to begin using the app. And then the menu provides a simple navigation to the home obstacle detections and history page. And The history interface presents a list of past detections with timestamp, allowing the user to review their recent navigation experience. And then lastly, the obstacle detection interface display the live camera feed and OLED bounding box on a detected obstacle, such as roadblocks and pole shown here. So below the video feed, a clear text area provide a contextual message like "Watch out! There are a pole and roadblock ahead." So I will conclude my presentations with the expected to achieve in PSM2. So first, I have successfully identified the core challenge faced by the visually impaired individuals through our literature review and observations. So I have pinpointed common obstacles like pothole, roadblock, and pedestrians. And I understand the difficulties in detecting these barrier in times, especially for older individuals with reduced mobility. Second, I will develop real-time mobile applications in PSM2, and this will be user-friendly app built with the Flutter featuring a YOLO VM model for object detections, and the model will be optimized with TensorFlow leads for efficient on-device performance, allowing the app to process live camera footage and provide immediate context-aware speech feedback. Third, the project will undergo a comprehensive performance evaluations. So the accuracies of my object detections model will be regularly tested using the standard computer vision matrices, including mean average precisions, recall, and the F1 score. And then the speech feedback system will be assessed for its naturalness and clarity using the mean opinion score to ensure its presence and easy to understand. So finally, I will conduct a user-centric validations. I will engage volunteers in the usability testing to confirm that the application is not only technically sound but also effective, reliable, and accessible in real-world situations. I think that's all of my presentations. Thank you.